we are live.
Hi Gautam, how is everything? Perfect, right?
Yes, perfect.
So we can start, right? Yeah, okay. Nimi, you can start.
Yes, hello everyone. A warm good afternoon to all those who have joined with us for today's session on budget astrophotography. This session is organized by Shasthra Snehi in association with Amateur Astronomers Organization, Kerala. I am Nimmi, member of Shasthra Snehi, here on behalf of the entire team. Extend my hearty welcome to all those who have showed up for the event today. I would like to take a minute from you to briefly introduce each of the organizations. Shasthra Snehi is a non-governmental organization focusing on the scientific empowerment of the society. We try to provide knowledge on the advancements in the field of science to people in a simple, attractive and legible way. Our collaborator, Astro Kerala, is an independent, non-profit, scientific, educational organization devoted to popularize astronomy and space science. Now coming back, our session for today, spanning from 3 to 4:30 p.m., is handled by the proficient astrophotographer and a keen science enthusiast, Mr. Sharath Prabhav, who is also the secretary of Amateur Astronomers Organization, Kerala. He has completed his post-graduation in physics from University College Thiruvananthapuram and is pursuing an MPhil degree in physics from the Cochin University of Science and Technology. He has also conducted several talks on astrophotography. Sir, we are highly obliged to have you with us for the evening. And now, to all the budding astrophotographers out there, we assure you that by the end of this session, you will have a good understanding of the basic camera settings required for astrophotography and would also have good command over the techniques on capturing the wide field objects with minimum equipments. Well, I know you all are longing to hear from the speaker. So with no further delay, I welcome our speaker for today with utmost respect and request to take over the platform for starting the session. Thank you. Over to you, sir.
Thank you, Nimmi. And first of all, thank you, Shasthra Snehi and the organizers. And also, I'm also a part of this organizing team. That is, I'm also a part of Astro Kerala. And thank you for giving this opportunity. So just a second, let me share my slides. Is it visible, Nimmi? Is it fine?
Yes, sir. It's fine.
Okay, thank you. So today, just a second. So once again, welcome you all the participants through the Meet, the Teams, and as well as from the YouTube. We have participants there. So welcome you all to this evening, this session on Introduction to Budget Astrophotography. So let me tell you some points about the overview or the outline of our course or this session. Basically, it's not a course. So I'm basically spending more time. I'll be spending more time on basics of photography and basics of astronomy. And there is a small session that is connecting them both, that is called the basics of astrophotography. So for photography or astrophotography, what we need to basically know how to set your camera for specific shots. So when you shoot for meteor showers, when you shoot for planet alignment, when you shoot for something called eclipse or then Milky Way. So for each of them, the settings will be different. So understanding each of them independently or settings for each of them independently will be difficult. So when you faced with a different kind of event, then you should be able to teach yourself, or you should be able to decide yourself what is needed. So for that, we are telling the basics of photography. By learning the basics of photography and the basics of astronomy, the basics of astronomy consist of only the basics that needed for astrophotography. So combining them together, you can yourself decide what kind of exposure, what kind of shutter speed, what ISO is needed for that particular shot. So that is my plan, not to give a very wide overview of astrophotography, and I'm not that professional astrophotographer. I'm an amateur astrophotographer, and specifically concentrated on wide field photography and some specific event photography. And I'm trying to move on to the second thing called the deep sky photography, and that is I'm only learning right now. But I will give you some glimpse of that, what we can do with a camera and a tripod. So this is the outline of the course. Then let's begin. So there is a famous quote that is called, "There are no rules for good photographs. There are only good photographs." So this is very important thing. That is, I am not going to teach you the rules of photography. That means there are no rules. We will learn only the camera settings, how each of the controls in a camera determine the amount of light entering and another aspects of a photo. So how to compose a photo, how to include things into the photo. Do we have to include the foreground or the background, whatever it is? That is the aesthetic part of the photography, or the artistic part of the photography. That is up to you. You can decide how to frame something and how to control the light, or how amount of light is needed. That all thing can be learned by yourself, or you may be well in that field, basically in photography. So I'm not teaching you about the rules of photography. We will be discussing the controls in photography. And also this quote is very important. That means there is no such rules. That means an autofocus photo can be very beautiful sometimes. A long exposure, a motion blur, a shaky photo, an overexposed photo, everything can be a good photograph in the perspective of photography. So it depends on what you want to shoot. So there is no certain rules for photograph. There are only good photographs. So let me move to the thing. So here we have some kind of cameras. Here you can see the smallest one sitting at the center is an Insta360, and the largest one is a DSLR. And you have mobile photos, DJIs, and GoPro kind of action cameras. Then the Nikon one, that is a mirrorless camera. And we have a very wide variety of equipments that needed or that are available to take photographs. So which of them you have to choose, which will be learning here? Oh, that is the question. So I'm not going into any of this specifically. Okay, maybe when discussing, I will be concentrating, or maybe discussing about the DSLR thing, or the digital DSLR and mirrorless thing, maybe. But it will be applicable to all the cameras as you see here. Not, you do not need an iPhone, and basically telling any camera with a manual control can be used for astrophotography or the wide field astrophotography in general. So the things that we learn in the coming slides will be applicable to all of these equipments where you can find a manual setting. Okay, so with that, let us go into a basic camera. So a basic camera will consist of a lens. That lens part, that's not a single lens. Here you can see you have multiple lenses are here. It is a set of lenses are there. Each of them have different purposes. So when we learn in the school classes, we learn that there is only a single lens. It is not the case. We have multiple lenses, and this lens will concentrate or focus the light, basically concentrate, okay, or focus the light into the sensor that is sitting behind the lens. So this is the sensor where it will record it into a memory card or whatever we have. So this is the basic construction of a camera, and this sensor will record the scene, or scene means what is seen by the camera. Okay, so basically what enters into this camera or what reaches this camera is the light. So we need to control the amount of light, or the amount of light that reaching the sensor. So for that we have different controls. And one more thing, in front of this sensor, so this is a CCD sensor that is called a simply a photoelectric device that converts photons or the light into electrical signals, and those electrical signals will be recorded and that is processed into a photograph. And in analog photography, instead of this digital sensor, here we can find a film. That is that old school photography thing that is called a film. So that is the basic functioning of a camera. And in front of this, you can find a shutter, and shutter will block the light at least temporarily from the sensor. And in a this is the structure of a mirrorless camera. For a mirror camera or DSLR cam, there will be a mirror which is used to see the live view. Okay, so I'm not going into that. If needed, we can discuss in the last discussion session what is the difference between both DSLR and mirrorless, and which is more better to use in astrophotography. So I will be discussing it later. Okay, so first thing, that is the exposure. So exposure means we know that that word is very familiar. How much the camera sensor is exposed to light, or how much light it can enter. So that is what is called the exposure. And this exposure can be controlled by three major things. That three things comes from these three basic questions. That is how long, how much, how sensitive. So how long means how long the camera sensor, okay, the sensor, you know, that sensor is exposed to the light, and how much means how much amount of light that it can enter through the lens. So that is about the how long and how much part. And the last thing is how sensitive is your sensor. You can make the sensitivity of the sensor amplified to a higher value or to a lower value. So that depends on the sensitivity. So three things, these are the three basic controls that that is there for photography. And there are many other things also, some white balance kind of thing. I'm not going to discuss that here, but basically these are the three controls that you find on a manual camera. So a manual camera means you will be able to control how long a sensor is exposed to light, how much light enters into the camera, and how sensitive is the sensor. So if you can adjust these three things, at least two of this, then we can say your camera, whatever be that, maybe it's a mobile phone, maybe it's a GoPro, whatever kind of camera, if you can control at least three of this, then you can say you have manual controls. Then if you have manual controls, you can shoot your desired kind of photograph. That is the advantage. You can control, you will be controlling how much amount, how long it should be exposed. So you will be the master of your camera, not the processor of the camera. So the things will be decided will be by you. So instead of deciding by the camera, we can decide ourselves using these three controls. So let's go into each of them. The first one is shutter speed. So before going into that, here you can see this is a DSLR camera, and here something is moving here. You can see the GIF animation. Actually, it's a video. Okay. So here you can see something is moving fast through here. This is a slow motion photograph video of that. And here you can see a slit. So this slit opening and this duration of the movement, you can see the this is actually 4,400 times slower. Just forget that. And that movement is slower, or we can control the speed of that movement. So by controlling the speed of that movement, we can, and also the opening, we can control what is called the shutter speed. So instead of seeing it something like this, okay, you can imagine it something differently. So imagine you have a sensor here. So you can see you have a sensor, and you can block the light falling on the sensor using a shutter. So you can imagine it as a cardboard or something. And whenever you need a photograph, you can remove that. Okay, by some mechanical means, you can remove that curtain or that blocking or simply a cardboard from the sensor. Okay, so in all the cameras, what they do is that they will open the front cap and they will close it. That is manually that done long before, in some 80s or 70s, they took photographs, something like that. You can still see such things in movies. Okay, so here you can see that. So you have a shutter. That shutter will block the light falling in the camera. So you can open it for a while to get the light into the sensor. So when you open it, you can control the timing, how long it should be open. You can open it for 2 minutes, you can open it for 30 seconds, you can open it for some 2 seconds, 3 seconds, or 1/60th of a second, 1/400th of a second, 1/2000th of a second. So you can control the amount of time that your camera is or the sensor is exposed to light. So that thing is controlled by the shutter speed. So if you need more, very simply, obviously we know that if you need more light to be collected, imagine that you are taking a photo in night. Okay, a night landscape is taking, your subject is a night landscape. Then you have to open the shutter for a long time. That means some 1 minute or some say 30 minutes may be possible. It is possible, but it will be overexposed. So you can open it for some 10 seconds or 30 seconds. You can control it. That is the advantage of that. So if you need more light, you can open it for a long time. Okay, it's fine. So if you need the more light, you have to open it for a while. Okay, and if you, but there is a problem. That is, we cannot call it as a problem, but there will be a another thing that is affected with the shutter speed. So here you can see 3 images of a toy paddle wheel or something like that. And you can see here the rightmost image here, that is something you don't feel that it is rotating. So this one, and in this one, you can see that it is taken with a shutter speed of 1/400. That means the shutter will open and close within 1/400th of a second. So you feel that toy is not rotating. That means it is staying stationary. But actually, this is a rotating. This is rotating actually. But due to the fastest movement of that shutter, we got a frozen image of that. So if you want to freeze something that is moving, you have to use a very high shutter speed. That means the shutter has to be opened and closed very fast. So in sports photography, you can see many of the photos that are taken with very high shutter speeds. So for that, you need a high shutter speed and that kind of special lens that is called a fast lens. I'm not going to discuss that here. Okay, anyway, so in the first picture and in all the 3 pictures, actually the toy is rotating, but the photo is taken with a different shutter speed. That is the only difference we have. When we have a very high shutter speed, the motion will be frozen. And when we have a very slower shutter speed, this is taken with some 1/10th of a second, the leftmost one, and the middle is in between. So in the leftmost thing, what happened is that during the 1/10th of a second, that is in some 0.1 second, in that 0.1 second, this is rotating. So the entire motion during this 0.1 second will be recorded into your sensor. So that is why what is called this effect is there. So if you want to feel that, if you need a photo that feels it is moving, you can use a slow shutter speed. And if you want to freeze something, then you can use the high shutter speed. So this is sometimes it is also a problem when you are shooting moving object. And this particular blur or this kind of effect is called a motion blur. So motion blur can affect your photograph in another way. So if you have a shaky hands and if you are taking a photo with a 1 second duration by hand holding, then what happen is that due to the tremor of your hand, the photo will be blurred, and we call it as a shaky photo, or there is a camera shake. So that is also a problem. So when you are using slower shutter speed, you have to stable your hand either by your hand holding, or you can use something called a stable mount, that is called a tripod for a camera. So either of this thing has to be used. Otherwise, you cannot go below a particular shutter speed without having handshakes. So this is the problem of, this is not a problem. There are this first picture, this exposure, this picture is actually taken with a longer shutter speed. So it's not a problem because during the entire movement of this, that is, it is some 1 minute exposure. In this 1 minute exposure, what happens is that the movement of the vehicles, that the light trail that is made by the vehicles will be recorded into the camera. That is why we get this light trail images. So we need a motion blur. Actually, you are using what is called a motion blur. So as in the first slide I mentioned, there are no rules for that photography. You can have a motion blur in the picture that can be a beautiful photo. So that's about it. Now the first, this thing what you have to take is that you have shutter speed. You can slower the shutter speed, or you can expose the sensor more time to gather more light, but the problem is that if there is any moving object in front of you, that will cause a motion blur in the picture. So the second control, the second important control in the camera is that is called the aperture. Aperture is much more simple to understand. That is, here you can see similar to that of an eye. There is a in eye you have the pupil which can be narrowed and dilated as you need it. The brain will control it. Here we can control it in a camera. So we have a diaphragm. So here you can see we can adjust the diameter, okay, diameter of that circular opening, and by controlling that we can control the how much amount of light is entering. So simply the diameter is larger, then more light will enter, and if it is narrower, less light will enter. So to gather more light, you have to open it wide, and if you need if it is a very bright day, you can control the amount of light by reducing its size. So that is about the aperture. It is a very simple control and it has an effect. So that effect will be discussed in this slide. So when you are focusing into a particular subject, imagine this first second man, that is, I'm going to focus at this this particular man, but actually the camera is focusing not to a single plane. So when viewed from here, this line is not a single point, but it has a depth. Okay, that means all the objects within this field, even if you are focusing to a particular point in a point or a plane in front of you, but everything something behind and in front of this will be focused. So that is called the depth of field of the camera. So everything in this in this range, this depth of field range will be focused in the camera. This is called the depth of field. So if we need a photograph that includes everything, this first man to the last man, then you need a very high depth of field. And if you need this particular man only to be focused, then you need a shallower depth of field. This depth of field can be controlled by what is called the aperture. So it is very useful in portrait photography that I will mention. Just a second. Here you can see that, just forgot about these numbers. We will come to that. Before that, here you can see the opening is very larger. So this is a very wide opened camera lens. So the diaphragm is very wide open. So here you can see the first pencil is only sharply focused and the second may be visible, and third or fourth are all got blurred. Okay, so here you have only the depth of field is, we can say that the first two pencil is the depth of field. In the second thing, you can see that the aperture is narrowed, the diameter is decreased, and you can see 3 pencil maybe, or the 4 pencil may be the depth of field. The 4 pencil means it's a measure of the length, how depth it is focused. And in f bar 32, or in the most narrow case, you can see that the entire image or the entire pencils are in focus. So this is a thing that we can use to control the depth of field. So as the diameter is very larger, then we can see that it will focus only to a particular plane, or the depth of field will become shallower and the depth of field will become deeper when you use a smaller opening. That means the value will be, and now you observe the values. Here we say that f bar is 2.8. That means 2.8 of opening will be a very larger one, and f bar 32 will be a minimum one. Actually, it is an inverse scale. It is calculated by the focal length divided by diameter of the lens. So don't bother about those equations and all things. Here you can see if f bar is 2.8, then it will be very widely open, and f bar is 32, it will be very narrow. Okay, so that is the relation. So here you can see this photo of a particular this rose flower. Here it is taken with the f bar 8.0, and in this figure it is taken with the f bar 3.5. Compare these two images. Here you can see in the first images, the top left one, you can see the it is sharply focused, and you can also see the background, some structures in the background. Okay, not exactly the background, but in the first, this bottom left picture, you can only see the that particular flower, and the entire thing in the background is blurred. So this kind of blur that is very useful in portrait photography can be used or can be established by controlling the aperture. So this kind of photos is taken using aperture control. If you have a wide aperture, then you can blur the background and the subject will be only the subject will be focused. So that is the advantage, or that is the effect of aperture, not only on the amount of light, but also it affects the depth of field. So now let's go into the next control. Okay, and it is very useful to use this f bar 32 or something. When you are f bar 32, we don't go to that much. F bar 11 or f bar something below 20 or above 11 can be used for landscape photography, where we need the entire thing to be focused. So from the nearest thing to the farthest mountains, and everything has to be in focus. So you can use an f bar 11 or above that. So that is the purpose of this control. So if you need a portrait photography, you can go for f bar 2.8 or something like that. Okay. So the next thing is the ISO sensitivity. So ISO sensitivity means it is basically a control that is it is a digital control basically. In the first two things what we've seen is actually controlling the true amount of light entering the camera. That means that much amount of light is only entering by controlling the amount of time and the amount of light that opening. So this is another digital thing, or we can call it as a kind of digital amplification. So what we do is that when ISO is increased, here you can see a miniature of that Eiffel Tower, that is 200, 400, 800 and 1600. Here you can see that it is improving the light, or the light is getting over, not overexposed, the amount of light is improving, okay, in that picture. But the problem is that, not the problem, what happens is here is actually, there is no physical improvement in the light, which is only controlled by the shutter speed and aperture. But what we do is that it is simply kind of a volume controller which can amplify the things. Okay, so similarly, we can amplify the light, that is, or the photons, or the current detected by the sensor can be amplified to get more light. So that is how ISO is adjusted. But for getting more light, we cannot go into a very larger ISO. Here you can see the first part of this picture, that is ISO 100, and the second part, the ISO is 3200. So what is the difference in between? The basic difference is that in the first picture you have a clean image, and in the second we have a noisy image. That means when you're amplifying something, you are not only amplifying the what is we needed, but also we will amplify the noise with it. So that noise will also get amplified and we get a noisy images. So we cannot always go to a very high ISO value. Maybe it is available to up to some 12,000 or 20,000 or so, but we cannot go into that because we get some noisy images. So we have a permitted limit that depends on your camera. Different camera has different maximums that we can use. So within that safe limit, we can use the ISO to be that. So now I'm concluding that we have three controls. One is the aperture, that is the opening, something like this, and we can there is a shutter. So here I'm taking an analogy, that is the amount of water collected by this cup, that will depend on three things. Not going into the first ISO, but this is exactly analogical. That is, aperture is exactly the opening of this tap, and shutter speed is how long you can open the tap. Okay, so these are the three controls, and we have ISO sensitivity. So we have to choose an optimum of this aperture, shutter speed, ISO sensitivity to get an optimum amount of light. Again, I am using optimum, or a desired level of light. So that desire is dependent on what you want to shoot. Okay. So in astrophotography, we can talk about it specifically, but in other things, that depends on the scenes, what you are shooting. So, and one more thing, we will discuss some photographs as an example, and what we have done there to get that optimum exposure. So this is another thing, this is called the focal length. I'm not going into the theory of that. Here you can see as the focal length of the camera increases, you get a narrower field of view, or you can literally zoom into that. So it is by adjusting the distance between the focusing point in the lens and the distance to the sensor. So focusing point and the sensor is there. This, by adjusting the distance between these two, we can improve, or we can have the focal length. So that particularly that physical distance is called what is called this focal length. And if you have a very larger focal length, something around 600 mm, then you can zoom into this. And if you have something 14 or 20 millimeter, then we say that it is something a very wide lens or ultra wide angle. And 24 mm, it is a wide angle, and up to 24 to 50, we can call it as a standard lens. And these are the just classification of lenses based on their focal length. So basically what we need to know that if you want to shoot something very far away, something like a wildlife, then you cannot go nearer to that. Then you need to have a very high focal length lens to zoom in. Okay, and there are cameras which can zoom in. That means it can vary its focal length. So focal length can be varied. That kind of lens is called a zoom lens. And there are cameras which have there are lenses which have a fixed focal length. They are called the prime lens or a block lens. Okay. So in astrophotography, these prime lenses are very good in capturing more light. We will discuss that. So this is about the focal length. So focal length is something that we needed later, and you can read the focal length from the camera itself. In the lens mount, there will be a marking for the what is called the focal length, and you can read it. So you have to read it to take astrophotography. So it is very simple. It can be seen in the cylinder of that lens. Okay. Then the next thing is some photographs I'm showing. So I'm just discussing how it is taken. Okay. Here in the first photograph, it is actually taken during an observation session in Trivandrum as part of ASTRO. And here you can see some stars in the background. Okay. And how it would be taken. So, and it is very noisy image. So it is taken in a night time, and it is used a higher ISO. That's why this picture looks so noisy. And in the background, you can see the stars. So to capture the stars, we need more light has to be entered, because the stars and the celestial objects are very far away from us, like order of light years. Then the light coming from those things will be very fainter. So we have to open the camera for a very longer time. So we opened it for a longer time. That is why the person sitting here he moved a bit. So that is why he find a ghosty effect or something, like a motion blur happened there. And this is obviously taken with a tripod, taken by stabilizing the camera on a tripod. So this is not the picture of the galaxy, something like that. This is a kind of cracker that we use using Diwali days. And here you can see that sparks or that ejecta coming from those that burned particle. It's coming out of this, and these flares will be completely recorded, because in this picture we used a longer shutter speed, something around 1/20 or 1/10 or so. Even though it is 1/10th of a second, this is a very fast moving object. So we got the track of or the trajectory of that ejectas from that, or the that sparks. So that is how we took this. And in this picture, we tried to grab the photo of a fly. And even though the shutter speed was very high, we cannot freeze the movement of its wings. Okay. And in this picture, this is also a long exposure photo, but you can see some spikes here. So, okay. This is something that we find when you take the photos of stars, especially when you look through a telescope. You can see these lines. Okay, this lines is actually due to an effect called a diffraction. That diffraction caused by light passing through this sharp edges. Okay, this tiny edges. You can see it's a kind of hexagon shape. So when light passes through these edges, diffraction happens, and thus diffraction causes this one. And this is another kind of a toy that consists of many LED lights. And when it's moved in front of the camera, all the trails has been recorded. So that is why it is something like this. And this is something out of focus. The background is out of focus, but still this background here you can see some blurry things. This is how all these things are actually out of focus, not this light or this particular thing, the subject, but the background. You see that you can see some bubbles there, circles. These are called bokehs. So bokehs are actually got by out of focusing the thing. So it is out of focus, and you can see that the only thing that is sharply focused is this particular one of this light. Okay, this one is particularly focused, and the background is completely blurred. That means we are using there is a very wide opened camera. That means we used a lower what is called aperture. And this is another capture of lightning. So when you see a lightning, it is a very fast moving thing. This trail has to be captured very fast. We may think that we need very longer shutter speed, but in this thing, we do not need a longer shutter speed. What we do is that the camera will be open for a 30-second or 40-second or so. So what do happen in between that 30-second will be recorded. So in that 30-second of duration, if you're lucky enough, you will get a lightning there. If not, you have to try it for a longer period. So we will take some photographs for 30-second duration. That means the exposure time will be 30 seconds, and we will take some hundreds of those photographs. When we have lightning there, then we get any of them will surely consist of this kind of pattern if you are lucky enough. So that is how we take these photos. So and now we can go into another part. So this is how you can analyze. I'm not going into the deeper details. You can analyze any of the photos that you see in Instagram or anywhere. You can analyze this, what they have done, what settings they have, they might have been used. Okay, maybe it's wrong, maybe it's false, and then you can try it by yourself by taking same kind of photos, and you can learn it. Okay. So the next thing is something about the shooting modes. So shooting modes is very important. So the first one I am talking is the fully automatic mode. That is first time we use with this fully automatic. So in fully automatic, we know that we have three controls: ISO, aperture, and shutter. These three of them will be defined by the camera itself. So the camera's brain will think for you or think for itself, and it will take a photo for you. That's it. So it will automatically controls ISO, aperture, and camera, ISO and shutter speed. So all three things will be controlled by the camera. So that is called the fully automatic thing. And in the manual mode, here you can see all the three things are controlled by the user itself. So this is the advantage of this. Even in the case of cars, we know that a manual car is cheaper than an automatic. But in camera, the manual camera is very important because we can do something creative there. That means you can decide it by your own, what ISO, what aperture, and what shutter speed we need. And there is something other two things that is to be important, that is AV or TV, or aperture priority mode or shutter priority mode. Okay. So in aperture priority mode, what is that ISO and aperture can be decided by ourselves, and the shutter speed will be decided by the camera. And in shutter priority, we can decide the shutter and ISO, and the aperture will be decided by the camera. So I'm not going into other automatic modes. Portrait is there, landscape is there. I'm not going into that. So these three things, that is program, aperture, this fourth thing, that is aperture, shutter, and manual. And program is something we can define, which has to be controlled. Okay. Anyway, these four things together is called the creative zone of the camera, which has to be used to learn. If you want to become a good photographer, you have to learn how to take photos with the manual settings. Now, one more thing that is very important in astrophotography, or as well as in normal photography, that is we can record the photo in two different formats. Many different formats are there for photos, but in a camera we can record it in RAW, and other is called a JPEG. JPEG is very common, we know that. So the advantage of taking a photo in RAW, it looks very dull, it looks very flat, it has a size of something around 25 MB or so. And in a JPEG, you can see that it is very good looking maybe, and it is compressed. Its size will be some 5 MB or so. So you can open it in every software. So when you hear about the RAW, we feel that it is a bad thing. But you know that actually the camera will record the raw data from the sensor directly into a memory card. That is happening in the RAW. But in the case of a JPEG image, the camera will record the RAW, and this RAW will be processed and then recorded as a JPEG. So during this processing time, a large amount of data is missed. So that you know that a raw photo will take some 25 MB or 20 MB of size, megabyte of size, and a JPEG photo will consist of only 5 MB or less than 10 MB. So half of its data is lost during this processing. So for astrophotography, or in if you are doing photography for creatively, if you want to be a photographer, then try to take photos in RAW, and then you can post process it at your desire. That means you can adjust the white balance, other color space parameters, and everything after taking the photos. When you come back to the home, you can do it in your laptop or PC. So that is the advantage of RAW. So in the case of astrophotography, we took the photo always in RAW. It is very space consuming, but it is. Now the next thing we want to know is about the sky. Just take a 1 minute break, not just a drink break. I'm not going anywhere, but just for
Yeah, sure.
Hello, everyone. In the meantime, I would like to remind everyone to just paste their questions in the chat box and we will ask them towards the end of the session. Thank you.
Okay, so I'm back. So in the first session, what we discussed is that about the photography settings. What you have to take from that is that you have 3 settings. Okay, that 3 settings is exposure time, or which is called the shutter speed. The next thing is called the aperture, and the third thing is called ISO. These are the 3 things that we need. Okay, that is the key points that you have to take from the first session. And how these things affect the amount of light in a photo. Okay, so if you need more light to be collected, the exposure has to be longer. The camera should be exposed for a longer time. In the second thing, that is about the aperture. In the case of aperture, the opening should be very larger to get more light, and ISO should be a permissible maximum. That means without grains. Then that is called ISO. So ISO has to be something like that. Then we get a maximum light, or a permissible maximum of ISO will give you a good exposure, good amount of light. So that is the 3 key points we have to take from the first part of this presentation. So in the second part of the session, we are talking about the challenges in astronomy, or not the challenges. Actually, the movement of Earth is the problem that we are having in astrophotography. So here you can see in this picture, this is not taken by me, it is taken from the internet. You can see that the stars are actually moving. This movement is actually what you are seeing is the rotation of Earth. So since the Earth is rotating, all the things that is in the sky, we feel it as it rotates around us. So we are shooting our subject is stars, and all these subjects are actually moving. So we have to take the photo of a moving subject. So that is a challenge that we have here. And we have a moving object is there, and the problem is these moving objects. So it is actually not moving, that we feel it is moving because of the Earth is rotating. And due to this movement, and these moving objects emit, okay, this so-called moving objects emit very fainter amount of lights. So this is a faint amount of lights. So this is the problem. Stars are very far away, so the amount of light coming will be very minimum, very faint, something we cannot see many of the things even with our naked eye. So we need photography techniques to shoot them. So the light coming from this are very feeble, and they are moving also. So this is the challenge that we face in astrophotography, that I will discuss later. Anyway, so just a second. Okay, so this is called the diurnal motion. That means simply the daily motion of the sky. So Earth is rotating some 360 degree every day. That means speed of 15 degree per hour. So this is the speed of Earth. So it is rotating 50 degree per hour. That means everything that you see in the sky will make a circle in a single day. So this is actually due to the movement of Earth. So this movement can be captured. Okay, here you can see we are it is captured, not we, somebody captured the entire movement of those stars, and this is called a star trail picture. Okay, we will discuss how to take that later. Anyway, this is actually you are seeing the movement of Earth's rotation, but we feel that all the other things are rotating around us. Okay, so something like a geocentric model actually. Okay. Now this is the rotation. So this is the daily motion of Earth. That is the only thing that challenges us basically. Yearly movement also influences. That is, we cannot see the Milky Way every months of an year. So you can have a particular period where you cannot see the Milky Way. I will not go into that. That is annual motion. So here the daily motion is something like this. So this is the problem that we are facing. So now one more thing, that is we have a celestial sphere. This celestial sphere is called an imaginary sphere. You can imagine it as we are at the center. The Earth, imagine the Earth is at the center, and we have a globe. The entire sky can be imagined as a globe, and every celestial event that is happening is actually happening in this sphere. So if you want to point something on the sphere, you can have some, we need something to point it. Okay, so it has a celestial pole. We are not going into that because it is not purely an astronomy class. Anyway, we can project our Earth's north pole to the sky and south pole to the sky, and we get the celestial poles, and we can expand the equator of Earth to meet the sky or the celestial sphere to get the celestial equator. Anyway, whatever happening on the sky can be assumed to be happening on this celestial sphere, a single plane. Assume it as a single plane, even though it is not so. So the thing is that when you are going to photograph some events in the sky, you have to know that where you have to point your camera. So at a particular time at the night, you can see ideally half of the hemisphere can be, half the sphere can be, or a hemisphere can be seen at a particular time. So at that particular time, you have a half of this celestial sphere, and in this celestial sphere where you have to point. So if you want to focus something, some cluster, some Messier objects or something like that, you cannot even see that with the naked eye. Then where you will point your object, or the where, to which location, to which direction you will focus your camera. That is the problem. So for that, we need to identify or we need a map of the entire map of the sky. So if we need to know something on a sphere, we have a map there. In the case of the globe, you know that there are countries, and land and oceans are divided into different names, and also, so we know that they are all there. Okay, this is something kind of a map. So for sky, we have another kind of map, which is called the constellation. Okay, we can divide it into countries or states or something. We can call that. Okay, and these states or these countries are called actually the constellations in the sky. So constellations is actually a region of the sky, not this particular shape. This is actually the region that is marked by this shape. Here, this marking is by the Leo constellation, which has assumed to have a shape of a lion. Okay, so the Leo constellation will represent this much thing. Okay, so when you have a comet is there in the Leo constellation, first of all, you have to know where is that Leo constellation in the sky. Then you have to point your camera to that Leo constellation. So that is the advantage of knowing the constellation. When there are newses about sky events, they will specifically written that it is in a particular constellation. Unless it is some moon or sun related events, then they will exactly say that they are connected to some constellation. You can that comet is visible in Orion constellation, or you can see the planet some Venus and Venus in this constellation, or Jupiter in another constellation. You can see that. So you have to know the map of the sky. That is basically the constellation. So for that, you can use sky maps, or that is one method to use the constellation. There is another more accurate method that we use in Earth, that is something called a lat and longe. So in like lat and longe, latitude and longitude, that we use on the surface of Earth, we can have two kind of coordinate systems, that is called altitude azimuth coordinate system and a rise, descension and declination coordinate system. I'm not going into that. That will take some 15 minutes more to explain all this. So anyway, there are two kind of things. This altitude and azimuth system is local, which can be used only to a specific region. That means maybe in Kerala we can use, or in northern district we can use, or in Trivandrum we can use a particular thing, but which we know which won't be applicable to somewhere in Delhi. So alt-azimuth is a local coordinate system, but right ascension and declination is a that is a global coordinate system, which will be accurate in every, or which is valid in every location on Earth. So this RAN deck is important when you are going into deep sky astrophotography or to the next level. Anyway, these are there. You can Google for more details. Now, the easiest way, I'm going into the easiest way, that is something called the sky maps. So here, leave this ISS tracker and heavens above. Here you can, familiar, these are some apps, okay, Android apps, that is, which are also available in iOS. Even in desktop PCs or laptops, we have apps and softwares are there. One of the famous is the Stellarium, which is available in PC also. Okay, in laptop can also you can install this Stellarium. Then we have Sky Map, Star Chart, etc. So what they basically do is that they can simulate the sky. Okay, it is something like a planetary software which can simulate the sky of any time at any location. Okay, so any time means the future or the past. So you can plan your events even before that. Okay, so if you have an eclipse some 1 month before, you can plan where to go and where to locate and which point will give you the most spectacular view of that, and you can decide all this by using the Stellarium. But the Stellarium kind of application doesn't include the weather. Okay, and that obviously the sky condition depends on the weather also. So for that we do not have these apps. There are other kind of apps I will discuss later. So those apps are there for predicting the weather, that you know, that you can just Google for the weather. That is the simplest way. So what these apps do is that they simulate the sky, and with that mobile phone in your hand, with the compass turned on, you can point the mobile phone to a particular constellation. Then it will automatically show the name of the constellation, name of that star, everything is there. So it is the easiest way, but the easiest way has some drawback, because you won't learn the sky. It is something like you are moving to some places with the Google location is or Google map is turned on. You won't learn the path. But if you go to some place by asking to other peoples and everything, then you will learn. Probably you will learn the path. Okay, route to there. So something like that. So if your plan is only astrophotography, then you can use the easy way. Otherwise, if you want to learn astronomy, I prefer to learn it by using sky maps, the printed sky maps, or by using some other books or something instead of using these apps. That is a better way. Anyway, if photography for photography purpose, we can use the easy way. Okay. Now we are moving. So this is the basic astronomy things. So what we have to understand is that everything is rotating in the sky. So that is one of the challenge, and everything is light years away. So the light coming will be very fainter. And you have to know before going into an observation or astrophotography where you have to point the point in the sky. For that we have constellations and coordinate systems, and the easy way you have applications are there. So now, so during the last 10 minutes of this session, I will briefly go into the astrophotography to the skies. We can point into the skies. So the minimum equipment, what I meant by what is called the budget thing, is that you need a camera. So camera is basically any type of camera which has the manual control, that is ISO control, exposure time, that is the shutter speed control, and aperture control. At least we need the exposure time. The shutter speed control should be there, at least minimum. Okay, then we can use that for some kind of photography. So you do not expect a very professional looking photograph from a mobile phone always. Sometimes you can get, but not always. Okay, so there will be a maximum level you can go with a mobile phone or any kind of camera or anything. So don't be too much confident about your mobile phone or anything. You can try by learning how this affects, then you can upgrade to any other devices, or you can learn from someone else. So here you can see that in this camera here, this 1/125, this is the actually the showing the shutter speed. That is, in this configuration it is 1/125th of a second is the shutter speed, and f bar 3.5, here it is the ISO. So you can control each of them. Okay, then this is a display of a GoPro. Here you can see white balance can be adjusted. Shutter here it is auto. We can change that. ISO can be adjusted. And in mobile phone, many of the camera, they have a fixed aperture. The opening will be the almost same always. So we cannot go for that. Anyway, the shutter control will be there. And in mobile phone, there are something called a manual mode or pro mode will be there. In that pro mode, here you can see that you can control the ISO, shutter speed, etc. So even mobile phone can record in RAW format also. That is, we discussed that a RAW format can be photos can be recorded in RAW format and even in mobile phones. So we need a manual control camera. Then we need something called a tripod. So this is something called a tripod. You can go to a very expensive to a cheap one. no problem, but that will affect your photo anyway. So the stable, do we need the stablest thing? Maybe, may not. Okay. Anyway, for a budget thing, some around 1,500 or below 2,000 is enough, I think, especially for a wide field photography. If you want to go for a specific target, something like a galaxy or a nebula, then we need very stable tripods. Otherwise, we need only this. Then we need a camera and a tripod. Instead of even using a tripod, you can use something like this, a bag which consists of rice. So this can be adjusted to get a kind of stable arrangement. You can adjust them to get a photo. Once I took a photo of Milky Way using some kind of this method, which is actually sometimes it is useful when you do not have a bulkier tripod with you. You can use this method also. And obviously, the last thing which we lack here in Kerala, that is the clear skies. I think we do not have even a week without rain. Okay. So the last and the most important thing is the clear skies. So these are the minimum equipments that we are discussing here. The maximum is very, very large and which is very costly. We can go to many other tracking instrument and many. So the settings, what settings we need. So we cannot go for a particular setting for a particular shot. Okay. So it depends on what you need to shoot. Okay, it depends on what you need to shoot. That means if you want to record star trail, then you need a particular setting. If you want to shoot the moon, then you need a particular settings. Anyway, I am giving you some basic ideas. So if you are okay. So for a lower shutter speed, the start will be trailing. So here you can see these are the photo of a night sky, but the problem is that here it is used a lower shutter speed. So when you have a very lower shutter speed, why you use the lower shutter speed? Because the stars are very faint. So you need to collect more and more light. So one of the things that we can do is that open the aperture maximum, ISO to a permissible maximum, that depends on your particular requirement. And the next thing what we can do is that I am putting my camera to a 30-second or 50-second or 1 minute of exposure. Then what will happen? So during this 1 minute of time, the stars are moving and those will be cause a trail of photo. So here I'm trying to photograph the stars, but I got only this kind of lines. That means your shutter speed is not that correct because you are getting lines, stars as lines. Here the problem is with the shutter speed. So if you want to take a photo, something like this, okay, something like this or this, then you need a longer shutter speed. You can go to your maximum or something like that. Okay, maybe may not be needed the maximum. You can take many photos and combine them to form this kind of circles. So these are not a single photograph. They will take many photographs and combine them. You can use that, but for a non-trailing photograph, so if you want to get the stars as a point object itself, then you have to avoid the trails. For avoiding the trails, this is the condition. There is something called a rule, that is called the 500 rule, popularly known as 500 rule or rule of 500. In that, you have to divide your focal length, 500 as divided by your focal length. Imagine that you are shooting at some 50 mm. Then you can divide it 500 divided by 50, you get 10. Then your shutter speed should be less than that 10 in seconds. Okay, less than 10 seconds to avoid trails. If you go about 10 seconds, some with a 50 mm lens, if you are shooting at some say 11 second or 12 second, then there will be trails. You have to shoot less than that. Always it is very good to go not too low, because if it is you are getting 10, then you do not use 9. Okay, better to use some 8 or 7. That is the best thing. And it also depends on the another thing called the crop factor of the camera. I'm not going to discuss that here. Anyway, you can try that. At least you have to be below this 500 divided by your focal length of your lens. So the focal length of your lens means you have to read it from the tube of that lens. Okay, so if you are shooting, you have a camera with 18 to 55, If you are shooting at some 24, then you have to divide 500 divided by 24. And if you are shooting with the same lens at 32, then you have to divide it with the 500 divided by 32. Okay, you have to divide using that number. Okay, so that is the particular focal length that is used, that you are going to use for that particular photo. So then there won't be any trails. So this is the easiest way to avoid trails. The second and the costly method is that I am not going to discuss that, to use a tracker. That means the stars are moving, so the camera can also move with that. There is a comedy in a Malayalam film, that is something Srinivasan is in a Srinivasan movie. I'm not okay. Hope some of you may know that. That means the stars are moving, so the camera can also track the movement. Okay, then what will happen? Then the stars won't trail, because the relative movement between the star and the camera can be made to zero. So there is no relative motion in between. Then you can go for longer exposure, but a basic tracker will cost something around 30,000 or something, the tracker itself. So you can avoid that. But there are any other method, you can make it by some DIY methods are there. I don't know about that. Okay, using some Arduino and other things, you can make something like that. So we are not going into that. So without a tracker, you can fix your shutter speed, that is to be less than 500 divided by the focal length of your lens at that particular photo. Now, the next thing is how to focus the sky. So here the problem is, it is a very faint situation. The camera won't autofocus. And it is always better to turn off the autofocus of your camera and go to a manual focus system. And in that manual focus, you can focus in two methods. The first method is called focus a bright star. So in the LCD, you can see in a live view, in the LCD, you can zoom in and focus a bright star in that sky. That is one of the method for focusing. Easiest method may be. The second method is that is called hyperfocusing. So hyperfocusing is something always used, very useful in landscape photography especially. So if you want to shoot the Milky Way with the foreground and the background, that means maybe some beach will be there. You need the beach and the sky together, or the landscape and the sky together. Then you know that sky is infinitely separated. Okay, and the sand or the beach is very near to you. So you have to keep this and that into focus. One method is you can take two separate photos of them and combine it together. And another method is called hyperfocusing. So in hyperfocusing, this is an app called PhotoPills. It is a paid app. There are many other apps are available there, or you can calculate it online. You have to search for hyperfocusing calculator photography, and you have to mention that specifically, hyperfocusing in photography. Otherwise, you will be drawn to some other things. So hyperfocusing in photography. So here what I do is that you have to choose the camera model, then the lens value. Lens value means the particular value of the focal length of the lens and the f bar. Then it will show the hyperfocal distance, that is called 127.68 meter. Okay, that means here what it means is that if you focus an object at 127 meter apart, then that is you need to shoot something near to me and very farther, that is infinitely separated. But you do not focus for the nearest object or the farthest object. You have to focus to an object which is 127 meter apart, roughly 127 meter apart. Then the entire thing, the foreground, the background, and everything will be in focus. That is a technique called a hyperfocus. So you can calculate it using some kind of app, and then you can use that particular value for focusing. So which can also be used in landscape photography. So this is the two methods for photographing. Then the next thing is planning. Okay, now in astrophotography, what we need is planning. So you need to know the weather, moon phase. The moon phase is important, not to take the photo of moon, that is also important, but to know if it is a brighter moon, that means a full moon day, then the sky will be entirely lighted by the moon itself. So you won't get a good photo of the sky. There will be light pollution due to this moon itself. Then you need to know the constellation where we need to know the events, what are the upcoming events are there, then know the location well before where you are going. You cannot shoot it from a city light. Okay, you have to go to some remote location, so it is better to know the location before. And if you have friends there, connect with them. And there is two apps are there. That is, one is Night Shift Stargazing in Astronomy, and this is something kind of a weather app, a sky weather app or astronomy weather app. It will exactly tell you what is the best time for looking into the sky and which location, and basically it will take the weather data also. Using that, it will predict today do we have to spend time for that or not. So Night Shift is a good app, and Moon Phase Calendar is there. Night Shift itself includes this Moon Phase also. So Moon Phase Calendar is it will show the moon phase on a particular day. So some interesting events are there. Events you can moon phases may not be an event. Eclipses are there. Meteor showers are there. Milky Way is visible sometimes some duration of maybe some March to October or something. It is visible in the sky, so you can take that. Planet alignments are there. Transit are there. Then occultations are there. Many events are there. Okay, so to know about the events on a particular day, you can go to this space.com, timeand.com, or you can Google for astronomy events of this month. You will be drawn to many locations. But before going into that, before going for a shooting, you have to make sure that this particular thing is visible at your location. Recently, we had an eclipse 1 or 2 weeks before, but a lunar eclipse, but it wasn't visible at Kerala. And I think it was even in India, it is only visible to some northern part of India. And then even it is, and it was partial also. So we have to know whether it is visible from our location. So for that, there will be eclipse maps will be there. You can simulate it on Stellarium like softwares. Okay. So now, how to take the photo of Milky Way. So Milky Way is best time to shoot it March to October. The next coming months are not good for actually Milky Way photography because it is Dhanu month. So this is the Dhanu Rashi, and which will be together with the sun. So we cannot see that. Okay. So for Milky Way, we need clear skies, we need a tripod, then f bar should be minimum. That means the aperture should be widely opened, ISO the maximum possible, then the shutter speed should be defined by the 500 divided by focal length. Then you can take the photos. And here this particular photo you can see at the right side is actually taken by using some sand and some cloth as a stable fix for my camera, not using a tripod. Okay, and it is best to take from rural places. So this is the idea is something very simple. Here you can see that the Milky Way you cannot see with a naked eye in most of the locations in India, but in some locations we can see that. But most of the location we cannot see the Milky Way. So it is very faint thing that you cannot even see with your eye. So for that you have to collect more light. So for collecting more light, what we can do? F bar should be minimum. That is the basic idea here. That is, camera should be open to its maximum. ISO should be its possible maximum without noise. Then shutter speed should be, we cannot go for a very larger ISO because the stars will trail. So 500 divided by focal length, then you can take the photos. So then the best time is March to October. You can use some Stellarium kind of apps to locate it where it is. Then the next thing is eclipses. For lunar eclipse, it is very simple. You can you do not need any other equipments. Even you can take it with handheld mode. So here it is a picture of a lunar eclipse. And for solar eclipse, obviously, do not point your camera, whatever kind of camera, do not point it directly to the sun. So for taking lunar eclipse photos, what you have to use is a filter. So here you can see this is a filter that is available in Amazon and some other websites. So this kind of filters can be used in front of your camera lens, and you can take the photos of eclipses. So for shooting sun, we need some special filters that has to be attached in front of the camera. And to get the camera or to get the moon exactly closer to us, we need a higher focal length lens, something like 150 mm or above, because we want to zoom into that. We need a telescopic effect there. So that is how we take the photos of eclipses. And this one is an event that is happening in between a solar eclipse, that is called a Bailey beads. Going into that is not an eyebrow kind of thing. Okay. Now the next thing is the meteor shower. In meteor shower, actually, if you're lucky enough, you can capture more than 3 or 4, or you can combine them. It is not so. It is only 2 of them in this particular shot. So meteor shower, you know that. For that, you have a list of meteor shower is available in Wikipedia, and you can. It is available in every month. There will be meteor shower, and the frequency of meteors per hour, frequency of number of meteors will vary between different meteor showers. And to take that, what you have to do is the idea of you cannot shoot that when you are seeing a meteor, you cannot click because it is a very fast thing. So what we do is that we will put it into a 30 or 40-second long exposure or 1 minute long exposure, and during that time, if you are lucky enough, a meteor will pass through the sky and will be recorded. This is the method you can use, and you can take many of the pictures and we can make it into a time lapse. So that is some other methods. You will take pictures, number of pictures over 1 hour or 2 hours, so then combine them into a single video. That is called a time lapse. Simply, that is a time lapse. So this is how you can. There is a meteor shower coming in the next week, that is 7th, and there is one in the January 1st week or 2nd week. There is a meteor shower. You can go for this is quadrant 28 to 12 December, January, and Gamma and Alpha Centaurids, and there are many. Okay, these are approximate dates. You can look for the particular date online for list of meteor showers or for a particular year. Now you can capture something called the constellations. So this is the Sagittarius, this is the Orion. For this, again, the stars should be stationary. You have to use the maximum here. Most of the settings for astrophotography is use the maximum ISO possible and open the lens as maximum as you can. That means the aperture should be maximum. So some of the prime lenses that we get in the market, they have a wide opening. That is why the prime lenses are very good in astrophotography. But zoom lenses usually do not have a very wider aperture. There are wider aperture lenses are there for with the zooming, but the problem is that they are very costlier. Okay, so prime lenses are some 35 mm or 50 mm primes are available. It's very good for photography. Some around 10,000 rupees or so. So for taking the constellation picture, you can say we can again put it into 500 divided by the focal length. Simply avoid the crop factor thing and divide by the focal length. That is the maximum shutter speed. You can take the photos. Then there are some other special events. These special events are, this is called something called an occultation. That is, here the Jupiter is, I think the Jupiter is passing behind the moon. So here we have a crescent moon is here. So you will see the Jupiter here later sometime. The Jupiter will reappear in the other side of the moon. So this is called this is, I think, in 2015 or so. So this is called an occultation. This is something called planet alignment. This is, I think, Venus and the moon, and this is also another planet alignment in the last December or so. Yes, December 21st or so. That is Jupiter and Saturn. This is actually not taken with this minimum equipment. This is actually taken with a something called with a telescope and a camera setting. So just leave that. And this is another photo which is taken directly, not directly, using a filter. This is what we are seeing here is our sun, and that particular spot is called the Venus. So this is the transit of Venus event, which is in 2012, I think. So there are some other events are also there. So you can find for them in online and you can take photograph of them. So now you can take the photos of moon. So there is a particular thing called f-bar11. F-bar11 is a best f-bar value. I don't know, it is an empirical knowledge. I don't know. It is actually, it's a practical knowledge. F-bar11 is best for shooting the moon photos. Then shutter can be 100. ISO 100, because the moon is very bright thing. When even if when it is very in some gibbous phase or something, so we can say that in quarters or something, the ISO will be, you can set it to 100, no problem, because even the minimum, that quality will be higher. So shutter is 1/100. That is, the rule is shutter should be 1/1 of ISO value. Then you will get a perfect photo. And lens greater than 200 mm is preferred. That is for a zooming effect and clear skies. Now there is something called ISS, International Space Station flyby. Here you see this line is the trail of the International Space Station, and you can find it using the ISS detector apps, and you can take this photo. This is taken actually with a long exposure within the permissible minimum. That is why we have the Orion constellation here, and this is the Sirius, I think, the brightest one, and the ISS is moved in between that time, and we got the entire trail of that. So this is called ISS flyby. Okay, I'm not going into that. The last step, that is the thing called stacking. The stacking method can also be applied to this particular thing called wide field astrophotography. So the idea of stacking is simple. That is, you have a limit for what is called shutter speed. So imagine that you have a 10-second shutter speed is permissible. So you took one photo, that is 10 seconds. You can take repeated photos, 10 second, 10 second, 10 second. If you take 10 photos of 10 second, that means you get 10 into 10, that is a total of 100 second of exposure. Then you can combine them together using some softwares. Then you get an effective exposure of 100 second. Or if you could shoot for 50 photos of 10 second, then 50 into 10, that is 500 second of exposure is available. So that is the advantage of taking to the next level, that is called the stacking. So stacking need a lot of patience. It is not that easy as you say, because you have to get very sharp photos, otherwise the software will reject your photos. And for stacking you need lights. So light frames are something called the direct photo of that object. Then there is something called a dark. So for dark frames, you will close the camera lens, and with the same settings of the light, you will click. That means the lens is open, you will get only some dark pictures. So this dark pictures will consist of the noise. So to this software, we will input this light, that is our data, and the dark file will consist of the noise. So we get the noise plus data will be inputted into the software, and this software will reduce the noise from this light file so that we get better thing. So there are also other frames called flats and bias. Not going into that now because the time constraint. So these are some method to take. This is the light frame, how to take. This is how we take a flat frame. And here you can see the comparison of, it is not taken by me, it is taken from the web. That is, this is a single 4-minute photograph, and this is the stacked photo of 4 minutes into 75, something around 600 minutes of exposure, I think, or 500 minutes of exposure is here, 600 minutes of exposure is here. So this is the effect of stacking. This is the second step you can move to. So these are some useful resources, sites, and Astro backward, and this Alan Valence website is here. Physics of Digital Photography. It is a very depth book. You can learn the physics of photography, but not about astrophotography. Some books are mentioned here, and that's for now. And thank you all. And this circle is a symmetric. The circle is made by a solar eclipse the last year, 2 years before, I think. So thank you all for being with me.
Thank you, Sharath.
Patiently.
This was really
so.
This was a very in detailed talk, today's one, and I hope I'm audible right now. Am I audible to you, Sharath?
Yes.
Right. So we are racking up some questions in the chat boxes, and I am going to just read one by one to you. Is that okay?
Okay. It's right. Fine. It's fine. I will try to answer them.
Yeah, it's okay. Yes, thank you. So the first question comes in that Microsoft Teams from Vishwajit, and his question is: I am an amateur too, and planning to purchase a telescope for astrophotography. My interest is in deep space objects observation. Please suggest a best refractor telescope. Also, how much millimeter, a camera, and software for image processing. I am a complete beginner.
Okay. As a complete beginner, do not buy a telescope. That is first thing I want to say. If you're interested in astronomy, when people comes to us, when we are taking, we and means even Gautam knows that which telescope I want to buy. That's a very common question we have. If you are a beginner, do not go for, am I audible? Okay.
Yes, you're on.
One error messages. Okay,
Yeah.
fine. So if you're going into, if you're a beginner, do not go into buying a telescope. Instead of that, you can buy, if you're interested in sky objects or something like that, you have to buy a binocular at first. So the binocular has one advantage is that you can take it to anywhere. You can take it to anywhere, and there is no need for an initial installment or installation process is there. So it is very easy to use. And it is very good for observing wide field objects, and you can use it for birding, wildlife observation are also. So the first thing, do not buy a telescope. Okay, first you go for a binocular and start to use or learn astronomy. And if you are getting interested more and more, then the next step you can go for a telescope. The second thing is buying a camera. So buying a camera depends on the amount of money that you can spend. Maybe possibly you can start from some 25,000 or above you can buy. So for astrophotography, as a beginner, it is the best thing to use your normal camera and its lens. So usually you get an 1855 lens with a camera, or you can change it to some, if you have money, you can buy more lens. So anyway, assume that you have a camera with the 1855, you can start from there by taking the photos of Milky Way and all that. Then you can change the lenses. Okay, then you can take the photograph. Now, the next thing is that when you are, if you are a serious, very serious and passionate astrophotographer, do not buy a reflecting telescope. You have to go for a refracting telescope. So refracting telescope is basically a lens, a very large lens. So those kind of things are there. There are many brands, but I think that is the next step. I think I don't know exactly the brands because it is very costly. I just know there are things, but I haven't even checked for the prices even.
I guess we should keep it into a lower budget, I think.
Yes.
Yes, all right. So the next question coming from this same person, Vishwajit, is that are FITS file kind of a raw file?
Okay.
FITS.
I think FITS file is actually, we got it from telescope data. That is that are FITS file. The pictures taken by Hubble Space Telescope are all available FITS data, and it is a kind of raw file actually. With the different data, not only the picture data is there, but many other data are also incorporated in that single file.
Like
FITS processing can be done. It is a yes. That means you can process the photos. You can take the photos and process, and you can send back to them. They may feature your photos sometimes. So it can be done. There is a FITS Liberator software is there where you can process this, or you can use the coding softwares like a Python or something for. That is another topic. I just done one or two times, but I'm not that well in that.
All right. Well, there is a different kind of question here from Avinash. He's saying that how can I join Kerala Astronomy Club? I am from Thrissur.
Okay, that means you mean amateur astronomer. I think Gautam know the real situation right now. Right now, due to the COVID, we are only working in an online form, Astro Kerala. But otherwise, we have had some kind of monthly sessions every month in the Trivandrum Planetarium. If you are interested in joining us, we have some contact points, many places, but we are not active in all the places in Kerala. So if you are interested, you can make a group of members, and you can contact us, or you can come to us to Trivandrum for our programs, or you can join online. astrokerala.org is the website, or astro.org is the website.
Okay.
AASTRO. We'll put in the chat.
Okay. And so I'm taking this next question from our viewer from YouTube, and his YouTube name is Asphalt Oreo. So, okay, I'll just read out the question. Hey, I'm trying to attach a webcam to my refractor. Already removed the lens and the eyepiece. Any good software to capture the images? I believe he's trying to connect the refractor directly to the computer. And so that's his question.
Usually when we are using that is called focal photography or something like that. I don't exactly remember the name. That is what we use is that we have the sensor of your webcam there, and we use the telescope to collect the light. Here, what you do is that we record it using the normal software. That is, you can have a specific recording software for the webcam, or you can use some automatic. I think there is Windows, there is an app, and there are many webcam softwares there. You can record it using that, and later there is a software called a Registax is there. Registax. Okay, so you can use the Registax to record them, to post process them. Basically, in webcam photography, what we do is that we do not take photographs, we record the video, then post process it is using Registax. So that is the method we usually see.
Okay, thank you. And we have another question from the teams by Kishore 20GP. So this is related to the astrophotography. Can you advise on planning and safety precautions while going to the dark place, like forest area, for low light pollution?
There are many issues. One is by the something like when you are going into that, safety means if you are going into some hilly places, you have to be careful about the depths and things, and some animals may be there, reptiles may be there. So these are some of the things that you know how to take care. I don't know what to say. The second thing is that from the peoples from there may be moral issues there. Why are you with some scopes? Are you for some kind of drinks or smoking or so there will be confusions from the people. So best thing is to interact with them. If you are alone, you can interact with them, then you can teach them what we are doing, and we are taking the photography, and usually in our experience that they will join with us. Okay, they will be happy about that. And if you have a binocular or something, you can show them, show them through that the sky, so they will be interacting with us more. That is the best way, instead of keeping away. That is the first thing. Or the second thing that you can use do is that when you are going to some places, you just find some friends or any friends from there, then you can join with them. And there are another kind of peoples that now another thing is coming up, that is with the resorts, somewhere Kodaikanal, Ooty, there are resorts. They are providing astrophotography and astronomy observation sessions there. Okay, it is actually getting popular now. So you can go there, you can observe beautiful skies there.
Right. So for this next question, I might have to rephrase this question. This is asked by A.K. Bala. Sir, just one moment, please. Okay, so this is about taking the photo of the meteor showers, right? So while taking the photo of a meteor, will there not be a star trail? And how can we avoid that star trail? That's the question.
So to avoid the star trail, the only thing is that we have to limit ourselves to the minimum. That minimum 500 rule has to be. That is the only way. There is no other kind of thing. But many of the videos that we see in the internet is actually taken with a star tracker. That tracker will move with that. So if you are going into the purely into the budget level, then the only thing we have is that 500 rule, and use a wide angle lens. So if you are using some 10 mm lens, so 10 mm wide angle lenses are again very costly. So these two extremes are always costly. The two things you can use is that one, use a low focal length lens, so that you will get a wide aperture, so you won't miss any of the meteors. And the second thing, you can go to a higher value. If you are using some 20 mm, 500 by 20 will be something around 25 seconds of exposure can be taken. The another thing that you buy a lens with a larger aperture value, some 2.8 or 2 or something, then you can get very beautiful sky along with this meteor.
All right. So the next question comes from Kishore, and it is like this: how you choose landscapes for wide field photos, and what is your favorite landscape?
That depends. Okay, I don't have such favorites because maybe I'm a beginner, that's why. How you choose landscape for wide field photos? Oh, maybe in case of astrophotography, Usually we took it from somewhere in Kerala or some in Tamil Nadu or something. We always use some hilly Wayanad or something hilly location. Mostly there will be some mountains or something like that, or anything. Anything can be used, I think. There are no such rules. We happen to be there. That is where we have only good skies there. That's why we are there. You can go for some desert beaches. Deserts are very good place, and beaches are very good place, and that depends on your creativity. We can make people in front of those Milky Way, and you can take the photos. So there are infinite possibilities. So I don't have a specific.
Right, so the questions are racking up again and again. So I'm going over to YouTube for now. And in YouTube, the latest question is from Astromaniac. They are getting more and more creative with their usernames.
Names,
So
yes.
Astromaniac just asked the question, can we have a live demonstration of using a telescope for the beginners in the next session, if that's possible for you?
Live demonstration of using a telescope. Oh, it can be done
For beginners.
later.
Maybe in the upcoming plans.
I think we can plan it together. Astro Kerala and Shasthra Snehi. It is very easy to with maybe with the corporation of planetariums also. We can do that. Surely we will look for that.
So Astromaniac, stay tuned. Right. So I have another question in Teams from Himani Parmar. I think I butchered that name. I'm sorry for that. But okay, on to the question. Sir, is there any way to take basic deep sky objects without tracking, with telescope and DSLR? I have a 8-second DOB, Nikon D3500, and I capture some planetary images too. I don't understand the DOB part, but
Dobbs-Bonian actually.
All right.
Okay. Without a tracking, it is very difficult because the focal length of an 8-inch Dobbs-Bonian will be something around some 600 mm or something. So one thing, maybe you can go up to 1 second exposure or so. So with that 1 second exposure, you have to take some 100 or 120 something that order of photos, and you can stack them. If it's a Dobbs-Bonian, so there is no tracking. So that is a better way to use. That is, you can take you have to read its focal length, the primary focal length, and using that primary focal length divide by 500 divided by that primary focal length, then you calculate that permissible aperture shutter speed and take photos with that value. So that is a method that we can follow, but it is very hard. Usually, maybe I think I tried it with some 6 inches, but it was disappointing. Maybe with patience you can do whatever you need.
And very steady hands, I suppose. So yes. Going over to AK Bala's question now from Teams. Why, sir, refracting but not reflecting telescopes? Because I have read that reflecting telescopes remove aberrations.
Aberrations, okay.
Aberrations, sorry. Yeah.
Okay, that is one reason I think. A reflecting telescope obviously removes the aberrations, but in the case of astrophotography, you know that there is actually the secondary mirror is connected to somewhere on the top of, or the secondary mirror will come in front of the primary mirror. That won't affect the visual view, but in photography that will affect actually. That is one thing why people avoid that. And so there will be the light, there won't be any, visually there won't be, but in photograph there will be a patch, a small patch will be there, light will be little brighter around the center. So that is a problem. The next thing is that when you are using an optical kind of telescope, entire thing is open. Your sensor is completely open to you're open. So it is very highly possible to enter some moisture then dust to your sensor directly. So that is why I think people have almost all the professionals use. I've seen that. I think this is the reason. This is my guess actually. So most professionals use this kind of pictures, and they use the tracking and post processing for getting beautiful images.
Okay, so the next question comes from Abhijit Air in Teams. Hi, good evening. What are the settings in Android phone astrophotography? Any specific app available for clicking?
Okay, before going into that, you have to check your camera has the manual possibilities. In some phones, the camera itself, the default camera will itself allow the manual things. In other cases, we have to install another photo taking apps, camera apps for that. There is some manual camera is there. Some other things are there. Just Google for manual cameras in Android apps. I don't actually use camera of mobile phones for astrophotography, but there are softwares available, and you can check whether your camera model provides a manual shooting mode. Okay, that means manual aperture, manual focus, and manual shutter. Then you can install, or some good apps are actually paid. You can install them and try for that. In recent days, I think we have this thing that is called the pro mode or manual mode is there in almost all the camp.
All right, so we are kind of constrained on time, so I would like to ask this one final question from Sri Bala.
Okay.
Though astrophotography sounds interesting to many, many still find it a strange thing to perform. Can you address in this?
Okay. Well, first thing is need lot of patience. That is one thing. The first time it will be very disappointing to take astrophotos. Mostly, if you're lucky enough, you may get something. But especially coming into, we have to find the best time. That is, we need a best weather, best shooting location. You have to travel a lot for particularly taking a photo, and you need to carry tripod always. So it is sometimes it is. I think that is the reason. But there are too many people is coming into this field, and we can see in Insta that is there are a lot of beautiful images are coming in the Insta feeds nowadays. So people are going into that. The second thing is that people are expecting too much in astrophotography by seeing the photos taken by using professional equipments. Some cost around some above 1 lakh. Some good trackers will cost about. You need trackers, you need high quality lenses, and using all these things they take good photographs. If you are expecting to take that kind of photos, you may not at the first time, but you can go on by starting. So the patience is the first thing we need. You have to spend more time and patience to take astrophotos. That is why it is
All right.
popular.
So I guess one last question, because Kishore seems to be enthusiastic about this. I have a reflector telescope. As you said, there is a shadow of secondary mirror visible in the photos when I take using my phone, keeping the phone on the eyepiece. How to get rid of this? And this will be the final question.
Okay. So actually, the reflector kind of telescope, which kind actually? It's a Newtonian or Cassegrain type? Can you?
It's not mentioned in the chat, but I guess you can just generalize it if it's possible.
Okay, so in Newtonian,
it's Newtonian.
Okay. It's Newtonian kind of thing. The problem is that the focusing point of the that is that thing has a focusing point inside it. So when you are this is about the connecting. Okay, I'm seeing the question right now. We are taking photos of phone by. Okay. If you are using the mobile phone, usually I don't see that. You have to just adjust the focus and try to make the object. If you have a particular object to be focused, then instead of keeping that object at the center, right center, you can move it just aside or something and use a low magnification eyepiece. Okay, then you can get a very wide field of view in that region, and you can move to a safer position. The object, suppose the moon can be moved to a safer position, and then you can take the photo. So that is one of the way we can use.
All right. So thank you very much, Sarath. Since we are constrained on time right now, it's already way above the set time limit. We are going to stop addressing the questions for now. And if I have missed any questions from the chat or from the YouTube, I apologize for that on behalf of Shasthra Snehi and Astro. And now I am going to move over to give this presentation to Nimi for the vote of thanks. Over to you, Nimi. Thank you.
Yes. Hello, everyone. We have come to the end of today's session, and it was indeed an interesting session. I'm quite sure that you all had a great time listening to the speaker, and I strongly believe that the session would have helped you to set a strong foundation in astrophotography. I would like to take this opportunity to extend my gratitude to the speaker, Mr. Sharath Prabhav, for spending his valuable time with us and ensuring that the participants get the fundamentals of the subject right within a short span. I also thank the entire team of Shasthra Snehi and Astro Kerala for their immense efforts in making the event a grand success. And last but not the least, I thank our audience for their patient listening and active participation in the session. Hope to meet you soon with another event. Have a great evening ahead. Thank you.
Thank you all. Thank you for joining the session.